Guys, welcome back to my channel. Today we will be evaluating this integral, this rational function. So we can do this by using the polynomial long division. So we can employ a polynomial long division. So we have our function in here, x cubed plus 2x squared plus x plus 1 divided by x squared plus 1. So how to do that is to take the first one, x cubed, and divide by x squared. So which is like x cubed divided by x squared, which will give you x. Put that here, x. Then you multiply x by x squared plus 1 again. Then you are going to get x squared. That will be x cubed, I'm sorry, plus 0x squared, because there's no x squared term here, plus x times 1, which is x. Then you subtract. So x cubed minus x cubed is 0. 2x squared minus 0x squared will be 2x squared, plus x times x minus x is 0, plus 1 minus 0, which is 1. So you are going to divide 2x squared by x squared again. That should give you 2. So you put the 2 here, then you multiply again, 2 multiplied by x squared plus 1. That should give you 2x squared plus 2. Then you subtract again, 2x squared minus 2x squared is 0. 1 minus 2, that should give you negative 1. So in the end, this is our quotient, or the answer, as a result of dividing this polynomial by this polynomial. So I can switch back to so this x cubed plus 2x squared plus x plus 1 all divided by x squared plus 1 can be written as the quotient, which we got to be x plus 2 plus the remainder. Remainder is negative 1. This is the remainder, which is negative 1, divided by the denominator, which is x squared plus 1. So this x cubed plus 2x squared plus x plus 1 all over x squared plus 1 should be equal to x plus 2 minus 1 over x squared plus 1. So instead of integrating x cubed plus 2x squared plus x plus 1 all over x squared plus 1, we will simply integrate x plus 2 minus 1 over x squared plus 1 dx. You can verify that this one, x plus 2 minus 1 over x squared plus 1, is the same as our original function. You can just multiply by x squared plus 1 minus 1 all over x squared plus 1, and you can simplify that out. So that should be x cubed plus x plus 2x squared plus 2 minus 1 all over x squared plus 1. So in the end, this is x cubed plus 2x squared plus x plus 1 all over x squared plus 1, which is the same as our original function. So we can't integrate this one, but we can integrate this. This now looks integrable. So we are now going to integrate x plus 2 minus 1 over x squared plus 1 dx. We can split this into 2, which is integral of x plus 2 dx minus integral of 1 over x squared plus 1 dx. Can call this one I1 and call this one I2. For I1, which is the integral of x plus 2. This is very easy by just using the power rule for this one. That should just be add 1 to the power and divide by the new power, plus the same thing here, which is just 2x. So this should give you x squared over 2 plus 2x. The second integral I2 is equals to the integral of 1 over x squared plus 1 dx. So we can use the trig sub. So we can let x to be equal to tan theta. The x d theta is equals to secant squared, implying that the x should be equal to secant squared theta d theta. So we can plug everything, take everything from the x world into the theta world. So that should be the integral of 1 over x squared. X is tan theta squared plus 1 dx is secant squared theta d theta. So this should give me integral of 1 over tan squared theta plus 1 times secant squared theta d theta. If we use the Pythagorean theorem, the trig identity, we know that tan squared theta plus 1 is equals to secant squared theta, which you can just plug into our integral. So I2 becomes integral of 1 over tan squared theta plus 1 is secant squared theta times secant squared theta d theta. The secant squared thetas will cancel out nicely. We are left with integral of 1 d theta. We are just integrating 1 in the theta world, which is just theta. But we have to go back into the x world because our original integral is in terms of x. So we knew that x was equal to tan theta. That is from here. In that case, we can find theta in terms of x to be the arctan of x. So theta in terms of x is the arctan of x. So I2, our integral I2 is equals to the arctan of x. So we can now put everything together. The first one, I1, our integral of x plus 2 minus integral of 1 over minus 1 over x squared plus 1 dx is equals to the first integral. At the first integral, the answer was x squared over 2 plus 2x minus the answer for the second one, which is just arctan of x. So, but this one is equal to our original integral, x cubed plus 2x squared plus x plus 1 all over x squared plus 1 dx. This should be equal to x squared over 2 plus 2x minus tan inverse of x plus the constant of integration. So this one is the value of this integral. We can confirm that by just doing, if you want to verify that this is the answer, you can differentiate what you got, x squared plus 2x plus 2 minus tan inverse of x plus c. If we differentiate this, we should be able to get x cubed plus 2x squared plus x plus 1. All over x squared plus 1. So that is the value of the this integral. So if you find this video helpful, like the video, subscribe to my channel, hit the notification bell, and I'll see you in the next video.